Hello everybody, I hope you are doing well. In this video, I'm going to talk about the strategy of solving problem. Based on this strategy, you can solve all problems in physics or any other sciences as long as you have some given information. There's a path actually from the starting point to the final point, which is what you're looking for. Sometimes if you have a simple question, probably you don't need to apply this strategy because you know that how to write down the right formula, and plug in numbers and get the answer. But sometimes the problem is more complicated. It's like exactly stepping into a dark room, so you are not able to see the other side of the room. So this strategy can be super helpful when you want to solve more complicated questions. The first step is just writing down all given information. So you are going to read the question carefully and find all given information and write down all of them together somewhere. We have two different types of given information. This given information might be given directly or indirectly. Directly means that like the number is given to the problem, like velocity equals 20 meters per second, or acceleration equals 1 meters per second squared. So these are directly given. But sometimes we have some also given information indirectly, like we have one object at rest. So that means that velocity at rest, at initial velocity equals 0 meters per second. Or we have a car which slows down to come a complete stop. That means that final velocity is 0. The second step is writing down what you're looking for. So you know what information you have and what information you're looking for, or what quantity you are looking for. The third step is pictorial representation. You need to use free body diagram or graphs or any other types of pictorial representation. Sometimes you can just take one of them or some of them together, and you can go back and forth between these pictorial representation to make them more complete. The step after that is writing down all the formulas that you think might be helpful or related to the question you have. Actually, we are looking for a formula to connect the given information and what we are looking for. Sometimes one formula is enough to get the answer, but sometimes we need some formulas in a chain to get the answer. And finally, after getting the answer, you will have uh, assessments step, which is the last step of the strategy, which means that you need to see if the answer that you found is reasonable. As an example, if you are trying to find the final velocity for a bicycle, and the answer that you get is something like 1,000 meters per second, it doesn't make sense because 1,000 meters per second means that in 1 second, bicycle should travel 1 kilometers, and it's not reasonable. So you can go back to the formula and check your calculation to make sure if something is wrong or not. So this is the strategy of solving problem that easily you can apply to all problems that you want to solve. I'm going to show you how to apply this strategy just in one example. So let's get it started. Here is the question we have. The question says a small rocket for gathering weather data has a mass of 30 kilogram and generates 1,500 newtons of thrust. On a windy day, the wind exerts a 20 Newton horizontal force on the rocket. If the rocket is launched straight up, by how much has it been deflected sideways? when it reaches a height of 1 kilometer. Because the rocket goes much higher than this, so assume here's no significant mass loss during the first 1 kilometer of flight. So what we need to do in this case is writing down all given information at first based on what we said in problem solving strategy. So I'm going to write down all given information, either direct or indirect information. The first one is the mass of the rocket, which is 30 kilogram. I'm going to write it down here. So mass equals 30 kilogram. And we have this thrust force, so I'm going to write it down here. If thrust equals this number. And then we know that there is a horizontal force from wind, which is 20 newtons. So F of wind equals 20 newtons. And then we know that the final height is 1 kilometer, which is 1,000 meters. So Y final equals 1,000 meters. We know that the rocket started launching from origin, so I have X initial equals Y initial equals 0 meters. And also we know that X final is the deflection that I'm looking for. So this is what I'm looking for. So as you can see here, I have all given information from the question and also what I'm looking for. The next step is pictorial representation. So first of all, I can just model the question by drawing a coordinate system here, X and Y. Let's say this is Y-axis and this is X-axis. This is the origin, so this is the first position of the rocket, which is X initial equals 0, and at the same time, Y initial equals 0. Then it goes up to the height of 1 kilometer here, but at the same time, because of the wind force, we have a horizontal deflection. So the final position of the rocket is somewhere like here. We know that Y final here is 1,000 meter. So I'm going to write it down here. Y final equals 1,000 meters. And X final, which is here, is what we are looking for. So this is the first actually model of this question. Also, in this case, free body diagram is another thing that can help us to solve this problem. So I'm going to also draw free body diagram. For free body diagram, again, I'm going to draw an X and Y direction, a coordinate system. So it's Y and X here. And this is the rocket at the origin. We have one wind force to the right, which is this one. So this is the force of wind equals 20 newtons. And also there is a weight, which is mass times gravity, gravitational force downward, which is something like this. I'm going to name it Fg, which is mass times gravity, 30 times 9.81 newtons. 9.81 is G, which is gravity, equals 9.81. And also we have a thrust force upward, so that would be something like this. And the magnitude of thrust force should be bigger than gravitational force, because we know that the rocket accelerates upward. So this is F thrust equals 1,500 newtons. So right now, by having this given information, this model and free body diagram, we have all information that we need. So the next step is just writing down the formulas that we can use to get the answer. We have two types of formula. One of them is the first type is for our formulas for Newton's second law and also kinematic formulas. So Newton's second law says acceleration in x direction equals all forces F net in x direction over the mass. So by looking at this free body diagram, as you can see, the only force we have is the force in x direction, is the force of wind. There is no any other force, assuming that there is no air drag in x direction and y direction. So here we are going to have just force of wind over mass, and we have these two given information here. Force of wind is 20 and mass is 30, so it's going to be 20 over 30 meters per second squared. In the same way, we are going to apply Newton's second law in y direction. So again, we have F net in y direction over mass, and in y direction, in this case, we have two forces. One of them is thrust force minus mg in this case, which is 30 times 9.81 divided by mass, which is 30. So let's write down the mass here. 30. And just by calculating this, you can find the acceleration in y direction also, which is meters per second squared. Then we have acceleration in x direction and y direction. Still, what we are looking for is x final. So we need to use also the formulas of kinematics in constant acceleration, because as you can see here, acceleration is in x direction and y direction. Both are constant numbers. So we are going to write down x final equals 1/2 ax t squared plus v initial x t plus x initial. Also, y final equals 1/2 ay t squared plus v naught y t plus v initial y initial. And based on given information, as you can see, x initial and y initial are zeros. So these two are zeros. And also initial velocities are zeros because the rocket started from rest. So actually we can write them down also here. That v initial in x direction equals v initial in y direction equals 0 meters per second. And we are looking for x final. So right now, easily from the second equation here, we can find t squared. T squared equals 2y final over ay. Ay is already found from here. So we have ay, y final is one of the given information. So easily we can solve it for t squared. And after finding t squared, we can plug in here to find x final, because ax also is found here. And this t squared can be plugged in here, and then easily we can find x